Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of circumference and area. This is 7.9b Readiness Practice, the advanced version. If you are interested in exploring the 7.9b Readiness Practice for the intermediate proficient versions or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. All right, so we have the center of a circular lawn. And we've already got the area that kind of works for us there. It is 296 hundredths square meters. All right, so let's put that in here. A equals 200.96 square meters. Now, we have a sidewalk, a width of 1 meter surrounds that lawn. All right, so let's see if we can draw a sidewalk around there and get it close to looking like it's uniform here. All right, so that needs to be a little bit bigger up there. So there we go. Let's say we've got that. That's going to have to be close enough. Now, what we do know is it's got a width of 1 meter. All right, so I'm going to zoom in a little bit here. There we go. Let's say that is going to be 1 meter. Now, what is the circumference of the outer edge of the sidewalk rounded to the nearest hundredth? So now I'm looking for this right here. That's my circumference. That's what I'm wondering what it is. Well, what do I know about circumference? Circumference equals pi times diameter. I don't know what the diameter is. If I could figure out what the radius is, I could double that to find the diameter. So let's look at our inner circle. Okay, so our inner circle right here. Just gonna kind of shade that for us real quick with this blue. So let's figure out what that is, because if I know what the area is, so area equals pi r squared. And then I can substitute in, since we're rounding to the nearest hundredth, I don't need all of it. Let's say our pi is going to approximate 3.14. So our area equals 200.96 square meters. All right, so I've got almost everything I need. Let's substitute. So I'm going to replace my A with 200.96. And I'm going to replace my pi with 3.14. And then I've just got an r squared. All right, so let's use our properties of equality. Let's divide both sides by 3.14 to get r squared by itself. Now we are going to have to do a little bit of long division here. So 3.14, 200.96. Let's multiply both by 100. You don't really ever want a decimal in the divisor. So 314 goes into 2,000. I'm going to say 6 times, because 6 times 3 is 18. Let's see if that's correct. 4, 2, that's 6, that's 8. 1884. I just need to subtract this, and it needs to be less than the 314. If so, we're good. That's 5, and that's just going to be 12. 125. Okay, we're good. 200 minus 188. You don't necessarily need to regroup if you can just add up. That's just 12. All right, so now I need this 6 down here, and 3 and 12. I'm going to go with 4. So let's go 314 times 4. That's 6, and that's going to be 4, 5. That's 12. Look at that, 1256. All right, so 64 equals r squared. All right, so I can take the square root of both, and since we're dealing with an actual shape, we can just take the positive root. R equals 8 meters. Now, how does that help us? Well, let's draw. I need to draw a purple line right here, and I'm going to draw it right here from our center over to our side. This is 8 meters. Now I'm looking for the circumference of the outer edge of the sidewalk, right? Because this Right here is our sidewalk that I'll just kind of put some orange marks in. That's our sidewalk. We need the outer edge of that. Well, all I need is pi and then the diameter. If the radius of the entire outer sidewalk is 9 meters, I take my 8 and then I add that 1 meter. That's the width of the actual sidewalk itself. Then I can say my diameter equals 2 times my radius. So diameter equals 2 times 9, which is going to equal 18 meters. All right, so now we can go back to this right here. We can say my circumference equals, let's use 3.14 times 18. Then we're good to go. All right, so let's do 3.14 times 18. That's going to be 32. That's 8. That's 11. 24, 25. Then on the next row, it's just times 1. So we can just type or write in 314. 2, 5, 6, 5. 2 digits behind the decimal. All right, so our circumference is approximately 56 and 52 hundredths square meters. And that is our answer. Let's put this in green. All right. So we are done with that and this circular sidewalk. So for number 2, we have a pizza parlor, large pizza, and it's got a circumference of 43.96 inches. All right, so let's get another circle here. This is our pizza. It's cut into 8 equal slices. All right, we can do that. So they're just going to give you a horizontal line. They're going to give you a vertical line. And then they are going to use the diagonals. All right, so there's your 8 pieces. We've got all the way around. Let's say C equals 43.96 inches. All right, what is the length of one of the slices of pizza? Well, take a look. If I take this one right here and I go up like that, look at that. That's my R. That's my radius. The length of one of the sides of the pizza is the radius. All right, so what do I know about my circumference? My circumference equals pi times diameter, or you can always think of it as 2 pi r, because the diameter is double the radius. And whenever you write it like that, you always put the coefficient, just the straight number 2, always in front. All right, so that's going to help me. So I'm going to replace my 43.96 for my circumference equals 2 times, let's put 6, or excuse me, 3.14 times the r, and then let's multiply our 2 and 3.14, then we're going to end up at 6.28 dividing. All right, so let's divide both sides by 6.28. 6.28. Do a little long division. 43.96. Multiply both sides by 100 to get rid of that decimal. So 628. I'm wondering if it can go in 7 times. I think that might be a little bit too big. Let's try 628 times 7. Sometimes you have to guess and check. 6, that's 14, that's 19, 42, 43. Oh, that's perfect. All right. So this is going to be 7, 43.96. All right. So this is 7 inches. Okay, so my length of one of my sides of pizza is 7 inches because that's my radius. R equals 7. So we could put this right here. Now, rounded to the nearest hundredth, what is the area of one slice of pizza? Okay, now this is where it's going to get tricky. Area equals pi r squared, right? Easy. That's for the entire circle. If I want to find just one slice, I want to find the area, and then I need to divide that by 8 because there's 8 slices. Okay, so just going to add one extra step. So 3.14 times 7 squared divided by 8. All right, so let's do some calculations here. We need to round it to the nearest hundredth. So it's going to be a little bit messy, but we're not going to have to divide forever. Okay, so the 7 squared equals 49. So 3.14 times 49 divided by 8. All right, so let's do 3.14 times 49. We'll divide that by 8. That's going to be 36. That's 9. That's 12. 27, 28. That's 16. That's 4. That's 5. And that's 12. 6, 8, 13. Now I need 2 digits behind that. That's 153.86 is approximately the area of the entire circle. But I want just one slice, and there's 8 slices, so I need to divide that by 8. 153.86. So this is going to be almost twice. That's 1. And then that is going to be 9. 72. Need a decimal right there. That's going to be twice. And that's going to be 16. That's 26. That's going to be 3 times. I'm rounding to the nearest thousandth, I believe. Hundredth, excuse me. So let me go to the thousandth and see if that 3 is going to change. So that's going to be 24. That's going to be a 20. And that's going to be a 2. It's going to go on forever, but I can just say that 2 is not going to change that 3. So I can say it's going to be 19.23, and these are square inches, is about the area of one slice of pizza. For number 3, we have a circular swimming pool, and the diameter is a decimal. All right, so let's get our circular swimming pool. Let's label it our diameter. And we can say all of this right here is 11.5 meters. All right. Needs a new cover that fits exactly over the surface. So to the nearest area, what is the area of the pool that the cover must cover? All right. So if we're looking at something that sits exactly on the surface, I'm looking for the area on the inside. Okay. So area equals pi r squared. And what is our radius? Well, our radius is going to be half of our diameter. So we need to take our 11.5, cut that in half, divide by 2. It's going to be 5. It's going to be 7. 5.75. So that's going to equal, let's once again use 3.14 and then 5.75 squared. All right. So that's going to be quite a bit of multiplication. So let's give ourselves a little bit of room here. I'll do it down here. First, I want to square the 5.75 times itself. And then we'll multiply that by 3.14. So that's 25, 35, 37. That's 25, 28. Let's get rid of those. And I've got 35. That's going to be 49. That's 52. 35, and that's 40. Now I already did a 5 times 575 on the first row, so I'm just going to copy out 2875, and we're good. So 5, 12, that's 10, that's 16, that's a 10, 13, and that's a 3. All right, so 1, 2, 3, 4 digits behind the decimal. All right, so what I have here is my radius squared is 33.0625. So let's take that, 33.06. You know what? I'm going to write that a little bit lower. 33.0625. Let's multiply that by 3.14. All right. So that's going to be 20. That's 10. That's 24. That's 25. That's 12. And then that is going to be 13, adding that 1. All right, let's get rid of these. Now, the second row, I can just copy down the 330625 because I'm multiplying by 1. Now, the third row, I need to multiply by 3, and then we'll be done. Then we'll round to the nearest thousandth. So I've got 15. That's 6. That's 7. That's 18. Obviously, lining up your numbers is going to be extremely important here. That is a lot of numbers. Let's add up 0, 5, 12. That is going to be 16. It's 11. That is 8, 10, 13. All right, I've got 1, 2, 3, 4, 5, 6 digits behind the decimal. 1, 2, 3, 4, 5, 6. All right, I'm going to the nearest thousandths place, right? Which means I need to go to the nearest 10 thousandths and look, and it's not going to do anything. So 103.816. So 103.816 meters squared. All right, so that is going to be our approximate area of the pool cover. Now, if the pool has a circular walkway around, all right, so another walkway. So let's get another walkway, and I'm going to try to make it a little bit better. There we go. That's going to have to be close enough. Pretend that's a circle, not an oval. And it is 0.75, so it's not very wide. Okay, so I'm going to do this in a different color. 0.75 meters. Okay, what is the total area including the walkway? All right, so I need to change my radius. My radius was 5.75. And so if I take my 5.75 and then I add my 0.75, I've got a new radius because I'm adding that walkway. It's going to be a little bit easier for us to multiply, though, thankfully. 6.50 or 6.5. Okay, so now my new area is going to equal 3.14 times 6.5 squared. So let's do a little bit more multiplication. Let's just square 6.5. And we're going to multiply that by 3.14. 25, 30, 32, 0, and that's going to be 30, 36, 39. And that's 25, that's 12, 42, 25. I've got 2 digits behind the decimal. And I'm just going to leave that right there. I'm going to multiply this by my pi equivalent, 3.14. It's 20. That's 8. That's 10. That's 8. That's 9. 16. Get rid of that. That second row is just going to be 4225 because I'm multiplying by 1. The last row I'm multiplying by 3, so that's 15. 6, that's 7. 6, and then that's 12. Let's add all of this up. 0, 5, that's 16. 14, that's another 16. That's 12. And that's 13. I need 1, 2, 3, 4 digits behind the decimal. 1, 2, 3, 4 digits behind the decimal. I am going to the nearest thousandth. So here's my thousandths. That zero's not doing anything. So I can say 132.665 square meters. All right, so that right there is the area of everything, of the pool and the walkway. Now, I need to find the area of just the walkway. Now, thankfully, there's not much left because you know what? If I found the area of, I'm going to shade this in this blue right here. Okay, so that area was the, what did we have? It was the 3.14 and the 575 squared. And then the bigger area was that second one, right? That with the radius of 6.5 because we added the 0.75 walkway. I don't need to do much more calculation. I've already found both, right? So this blue one right here was 103.816. This purple one, we just figured out 132.665. So then if I want to find just the walkway, I'm going to take the entire circle, the 132.665, and I'm simply going to subtract the area of the blue, the area that I don't want to count, which is the pool itself. 103.816. If I do that, you know what's left? Just the walkway. So it might seem like this is going to be difficult, but this is actually the most simple calculation we've done because we're just doing simple subtraction. 9, that's a 4. Then we do have to regroup on most of them. That's an 8. That's an 8. That's a 2. All right, so it looks like we're going to have 28.849. Now I need to give myself a little bit of room here. So let's erase those. And let's write 28.849 meters squared. Because I just took the area of the part that was missing. And those are our 3 answers. If you are interested in exploring the 7.9b readiness practice aligned with the intermediate or proficient versions, or the readiness practice resource aligned with any other standard, you can find those by using the link in the video description.